Oh yeah, I could.
Yeah, there was like 7 or 8 in the other one. You might want to.
Need to run a design. That's the initial idea. But it would simplify deploy daemon services in DQI a lot.
Yeah.
And yeah, we take away from multiple rows. Just coming in. There's another piece. You need daemon API anywhere. It cannot be right API. So API to install that.
Did you make it? Did you make it?
API.
Did I make
That
what?
could be math.
It should be in there.
Now they are
That's my screen there.
So the reason for a framework is for future that you hack
Oh, did you already do that?
sort of like
Is anyone still in the previous channel? No?
the previous hangout.
Yeah, the wrong link that people went to?
Not
Or do you mind telling people if there's anyone in there?
sure.
Yeah. You're gonna share the screen. Great. All right, let's get started. We have quite a bit of people today. Let's see. You want to just go around and say your name briefly and just where you work, and we'll start with the demos today. Kevin's going to start first, and then we'll have Neil go afterwards. We'll go through the roadmap briefly and talk about the 1.2 release. I'm not sure who added that one, but we know about it. Okay.
We can do that agenda stuff first and then do the demo. That feels more natural.
I'm not sure if we'll get to the demos if we start with the agenda stuff.
Yeah.
Okay, fair
Because
enough.
the agenda stuff tends to run longer than we expect. So let's get the content out of the way. Because I think they're people. So yeah, let's start with introduction. We'll go around this way.
Can we skip the introduction or we can
I don't know, does everyone pretty much know each other?
yeah.
Yeah.
Not people online.
I don't.
Yes, some people online.
Maybe like
Yeah, Vishnu, we
Okay,
have
so
Gilbert, we have Vital.
and everybody that's on YouTube.
David.
How many?
David and Fran. You,
So people.
I guess you want to introduce yourself, David and Fran. I don't know if they're on the.
Are they able to hear us? Can they hear us? I can see. I can see the.
Vishnu, are you able to hear us?
Yep, go come in loud and clear.
Yeah, I can
So I don't know some people.
Okay. Okay. Great. Let's do that.
Oh, so I don't know her.
Hi, I'm Meka. I work at Apple, same team as Ian.
Okay. Cool. What else? I don't know things. Well, if everyone knows how to work.
Well, I guess we haven't met.
Yeah, I'm Sam, but I work on the DCOs.
Oh, okay. Yeah, no.
Perfect.
Alright.
You look familiar.
Yes, that's what I was
All right, okay. Let's get started. Tom, do you want to pick us? He's going to support, present debugging support in Mesos. He gave this talk at a meetup late last year, right?
Yeah, a couple weeks ago.
And he's here to share with us what he presented there.
Okay, yeah, thanks. Yeah, so as Michael said, I'm going to present some of the new attach and exec support that we added into Mesos over the last few months. At a very high level, what we basically did is we've tried to add functionality to Mesos that enables building tools that mimic functionality similar to Docker attach and Docker exec. So if you're familiar with those tools, you can now do very similar things with Mesos. One sort of big difference, though, is that instead of needing to have everything running locally on your client, you're able to actually do this remotely and attach to a remote agent and stream all of your output back to your local client using streaming HTTP requests and responses. And there's no need for SSH access to the node where your task is actually running. Everything is authenticated through the Mesos authorization and authentication mechanism, and it's streamed over HTTP. The signatures for the different commands, so we have some APIs that are in place to enable this, and the idea is that we built some command line tools around it that look similar to the two that you see down here. So if you're familiar again with Docker exec and Docker attach, these should look very familiar because we basically mimicked exactly at least the signature of the commands for that. So you can say, you know, instead of Docker exec and then some command with its arguments, you say Mesos task exec and Mesos task attach and so on. Specifically, some of the details, I won't go into all the details about how we built this, but at a very high level, the way we enable the exec-like commands is what we basically do is we leverage the nested container stuff that we added to support pods back in September to allow us to now launch a new nested container whose life cycle is tied to the lifetime of the connection. So when you do a Mesos task exec command and you access this through the API, you're going to launch a nested container on the agent that you're connected to. And whenever that connection dies, your nested container will disappear. So it's a little bit different than the way you normally launch containers, where there are these long-running things running in the background. It's tied to the life cycle of whatever connection you happen to make. Because they're nested containers, they're isolated in the same set of C groups and the same namespaces as your parent container. They're slightly different than normal default style nested containers. In that everything is actually shared now instead of having some things that aren't shared. So in normal nested containers, for example, you might be able to provision a new file system or say that you want a different network namespace and so on. With these ones, you actually always get the exact same C groups and same namespaces, and everything is shared. And then, you know, as you would expect, we're then able to stream the input and output of the command back to your local terminal. So it's running on the remote machine as a nested container inside your parent container, and all of the standard in and standard out is redirected as expected.
Does it require a task group, or does it require the default executor?
It does not require the default executor. It doesn't require the default executor. It doesn't require task groups. It's its own separate API call that you make against the agent. And so instead of going to the master, you have to launch a task group and get these things up and running, and then nested containers sort of fall out from that. This is actually I know the parent container ID I want to debug, or that I want to basically exec into. I directly launch a new nested container inside of that through a special API call, which is called launch nested container session, which you'll see in a second.
Yeah. You support command executor.
It supports the command executor.
Yeah.
But custom executor is support as well, as long as you launch after you switch to a new version of Mesos. So you cannot attach to a container that's previously launched by Mesos, like 1.1.
Yeah. Only so if you have
all
long
new
things
ones.
that have been there for a long time, you're not going to be able to exec into those or attach to those. Right now, we've made the limitation. We might revisit this later, but currently it's only possible to attach to tasks that are launched with a TTY. For the exec commands, you can exec things without a TTY. They don't have to be interactive. They don't have to be anything. But if you're actually going to attach to something, some long-running container that you've already started and launched in the cluster, in order to attach to its input and output, it has to have been launched with a TTY. There's a brand new capability that we added to the container config. So old containers that you have running in your cluster already, you'll never be able to attach to, but new ones that you launch with a TTY, you'll be able to. So how did we go about doing this? This is just a real quick high-level architecture diagram showing some existing components that we already had in the system and some new components that we had to add to enable this. So first thing to notice is all the way on the left, we have a new set of agent APIs that we added. I'll show these on the following slide. There's basically 3 new APIs to an agent that you can interact with in order to run, to build these exec and attach type operations. There's a set of handlers that are able to, interpret these API calls as they come in, pass those off to this new component that we call the IO container switchboard. And then that will in turn launch a separate process per container that's in charge of sort of redirecting all of the input and output that's being generated by a container and passing that back out through any API calls that have been attached to it. Does that make sense? So per container, now if you want to be able to exec into it or have a attached to its input and output, there's going to be this separate sidecar process called Mesos IO switchboard that's running, which handles all of your input and output and redirects it in all directions. So the 3 API calls themselves, they're listed here. The first one is launch nested container session, some combination of streaming requests and streaming responses. The launch nested container session itself, what it basically does is once you initiate that, you initiate it with a single, fixed size request that hits the agent. The agent says, okay, I'm going to launch a new nested container. I'm going to run whatever command you told me to launch with it. And any output that generates, it's now going to stream back over an HTTP streaming response back to the client. If you optionally want to attach standard into this, you can then follow that call up with a second attached container input call, which actually uses a new HTTP streaming request mechanism that we added so that you can send chunked HTTP requests over to the agent with one persistent connection feeding the standard into whatever nested container session that you previously launched. Those are the only 2 calls that you need in order to accomplish an exec, because we sort of piggyback the output back on the response of the launch nested container session that you initiate. If you want to do an attach, you don't need a launch nested container session because you're now attaching to something that's already running in the cluster. And instead, you use a combination of attached container output with attached container input, where the attached container output is just a simple call into the agent, and then you stream the output back without launching a new container. Does that make sense? As I mentioned before, this is fully integrated with Mesos's built-in authorization and authentication mechanism. Going a step further, it's also fully integrated with DCOS's authentication and authorization mechanism. And as I'll go through a demo that I have in a second, we've implemented this into the DCOS CLI, and I'm going to demo this with a running instance of DCOS and bringing up an Nginx container and trying to debug it and do some things around that. And because of this, you're obviously only allowed to exec and attach into the tasks you're authorized to access. So instead of having to SSH into the box and give SSH keys to all of the people to allow them to log into the box and then try and debug however they normally would do it that way, now you can debug into the container using attach and exec with Mesos' authentication authorization. Status of this, the APIs themselves are fully implemented in the Mesos agent. We have a reference implementation of consuming those APIs in the DCOS CLI. And we have a native Mesos CLI component to this coming soon. So it's not built into the Mesos CLI yet, but I wrote the DCOS CLI portion of this. So it should be a pretty easy backport to the Mesos CLI once I find some time to do that in the next couple of weeks. And so as I said, in the demo, I'm going to use the DCOS CLI and interact with DCOS just so you can see how this all works. The demos themselves, I basically got 3 demos I want to show. 2 of them interact with Mesos itself without any DCOS component at all. You can actually configure the DCOS CLI to connect directly to Mesos if you put it into a special mode. So if you wanted to play around with this today, you could download the DCOS CLI and use it as if it was the Mesos CLI to start debugging your Mesos stuff right now. The way I'm going to set these demos up, at least for the first 2, is I'm going to have a single Mesos master running on localhost. I'm going to have a single Mesos agent running on localhost. And I'm going to launch an NVIDIA CUDA Docker image inside of a task. And all that task is going to do is sleep for, infinite amount of time, or 99999 seconds. and I'm going to allocate it a GPU. And the main reason I want to do this is I want to show that, oh, I can launch some task. I can then launch an interactive bash session inside of it and then sort of see, okay, what's going on in here? Was I really allocated only one GPU from the total amount that I should have seen? The resource allocations actually set up properly and so on. And then in the third demo, I'm going to bring up a full-blown DCOS cluster running Marathon and Metronome. And I'm going to show how you can debug a running Nginx instance inside of this cluster. And like I said, I use the DCOS CLI for all of these demos. So some of the details real quick about the demos I'm going to do. The first one is going to be the simple hello world demo where I'm going to take this hello world SH script, which all it does is echo hello world back to the terminal. I'm going to first upload that script to the tasks container using sort of a poor man's SCP, where I'm just catting the file and then piping that into to the standard in of my DCOS task exec command, which forwards that into the container because I then run the command bash. So I'm just copying the file over and giving it the same name. And then I'm going to use DCOS task exec to add proper permissions to the script so that I can execute it. And then I'm going to execute that script inside the container via DCOS task exec and then run the hello world sh script. The second one I'm going to do, like I mentioned before, I'm going to quickly run NVIDIA SMI on the host to show you, hey, on my host machine, I've got 4 GPUs that I'm capable of handing out to some task. And then I'm going to start an interactive bash session inside that container or inside that task. And I'm going to set up some environment variables so that I can actually interact with the NVIDIA libraries that are installed inside that container. And then I'm going to run NVIDIA SMI and show you, yes, indeed, I only am able to see and interact with 1 GPU that's been allocated to this task. And as I mentioned before, the third demo, I'm going to bring up a vanilla Nginx container running inside of DCOS. I'm going to verify at first that nothing's serving on whatever port I've allocated to Nginx, because by default, I allocate some port to Nginx, which isn't port 80. But if you just install the vanilla Nginx Docker container, it's going to think it's running on port 80, so you have to change that up a little bit. I'm then going to start an interactive session with that Nginx's container. I'm going to update it to the port that we've actually allocated it to so that it can be listening and serving something on that. I'll restart Nginx, and then I'll show you that, yes, Nginx is actually up and running now. So sort of walk through this process of something went wrong with my container in the cluster. How do I debug that and then fix it and get it up and running again? So with that, I'll jump to the demo. So I've already set some of this up, as I mentioned. So I've got a Mesos master running locally. I've got a Mesos agent sitting here running locally. And the first thing I'm going to do is I'm going to use the Mesos execute script to launch this long-running container. For now, it's just sleep forever kind of thing. The name of this task is GPU test, and I'm going to allocate it exactly 1 GPU. That's sort of what this last parameter that's cut off on the under the screen is. So if I go ahead and launch that guy, I don't actually need sudo here. So I go ahead and launch that container. If I then pop back over to, so now what I basically have listed here is all of the commands that I'm going to run for each of these demos. So the first demo, the very first thing I want to do is I want to configure DCOS to be able to run against a Mesos only cluster that doesn't have DCOS installed. So I'm going to run that first command, which points the DCOS core.mesos master URL variable at my local host. So I go ahead and do that. It's now set up for that. And then I'm going to create this hello world.sh file locally. And then I'm going to, as I mentioned before, I'm going to copy this up into my container running inside the task container. I'm going to give that file some executable permissions. Okay. And then I'm going to run DCOS task exec and execute that hello world sh script from inside the container. As you see, we get, that went through this whole process of calling those APIs, streaming everything through standard in, streaming everything through standard out back, and then printing to my local terminal. So that's the first demo. Second demo, as I mentioned before, first thing I want to do is just show you on my local host without doing a DCOS task exec. I'm just going to run NVIDIA SMI. That shows that, hey, I've got 4 GPUs on this machine that I could have allocated to my task, allocated at 1. So what I'm going to do is I'm now going to open an interactive bash session with that running task. So I do a DCOS task exec. Oops. I'm now inside that container as the root user. I can navigate around, do whatever I wanted. But the main thing I want to do is I want to set up some environment variables to allow me to interact properly with the NVIDIA libraries installed on this inside this container. So I go ahead and do that. And now I'm going to run natively, or sorry, now instead of running on the host, I'm going to run this NVIDIA SMI command inside of my container. And we see, okay, I've only got one GPU that's been allocated to it. So, you know, I came in, if for some reason something had gone wrong, I would have been able to come in and debug, okay, why do I actually have 2 GPUs when I was supposed to only have 1, or did allocation actually happen properly, and so on. So, you know, interactive bash session, go ahead and exit out of that. Okay, so the third demo I wanted to do is now with a full-blown DCOS instance. First thing I need to do to get this going is I'm going to reconfigure my DCOS CLI to not point at a native Mesos master anymore. I'm going to point it at a DCOS cluster that I previously got spun up and running. I'm then going to log into that cluster with by default, when you bring something new up, the user is called bootstrap user, and I guess I won't tell you the password, but oops. So that should log me in. Great, I'm logged in. So I'll go ahead and go real quick to the UI here to show you. This is the cluster that I have up and running. Currently, there are no services running at all. So the first thing I'm going to do is I'm going to install some Marathon app some long-running Marathon app that has Nginx as it's based on an Nginx container. So if I go ahead and open up this nginx.json file real quick, you can see what I'm actually going to install on this. So I'm going to have an application called Nginx demo. I'm running it using the unified Mesos containerizer. The Docker image that this is going to be based off of is the standard library Nginx instance or Docker image that I want to base this off of. I'm going to run, again, this long-running command so that I can come in and interact with it, you know, when it doesn't complete on me. I'm going to give it 0.2 CPUs for a single instance, and I want this to be a public slave. And the reason I want it to be a public slave is so that I can go specifically to its URL and access it without having to go through some of the DCOS magic to try and find it in the cluster. I just wanted to be, for demo purposes, as simple as possible to figure out where this Nginx instance should be up and running. Okay, so with that, I'm going to go ahead and deploy that application inside DCOS. So I say DCOS Marathon app, add that, and it says, great, I've gone ahead and created that deployment. So now that that's there, I can come back to the UI and I see, okay, here's this Nginx demo that's running. You can see that it thinks it's running. That's great. So it actually spun up and is trying to serve something somewhere. And what it tells me is that the endpoint it should be running at is this 10.05.164 on port 8316. So I go ahead and click on that and say, great, I want to see my Nginx instance running. Okay, it popped up, but why isn't it working? Well, the first thing you notice here is this is actually an internal IP. So somehow I'm going to have to figure out what is my external IP so that I can actually go ahead and access this Nginx instance as it's running. So the first thing I want to do is say, okay, well, what is my public IP? So what I would want to do is I'd want to say, okay, well, I'll run DCOS task exec on this container and try and curl this special URL that Amazon gives you that lets you say, hey, what is my public IP address? If you curl this magic URL, Amazon gives you that back. So what I want to do is first run that, and it says, oh, no such file or directory. Well, why did that happen? It actually happened because the default Nginx container doesn't have curl installed on it for whatever reason. So I say, okay, well, that's unfortunate. How can I fix that? I'll come in, run DCOS task exec to give me an interactive bash session in there. I'm going to update the container by running apt-get to install some new binaries inside here. I'm going to now install my curl command so that I can go ahead and use it. I'm then going to rerun the command I tried to run directly up here but I'll run it from within the interactive bash session now. So I go ahead and do that. Oops. And when I do, I see some public IP pop out of this. So great. I'll go ahead and grab that guy. I'll come back to the UI, and I'll try and now access it over its public IP. But again, because Nginx by default serves on port 80, not on this random port that I happen to have allocated it, I'm going to need to go in and reconfigure Nginx to serve on this port instead in order to actually get this up and running and see some output from this. So if I come back to the set of commands I want to run, I could exit from this, but instead of exiting and coming back into bash, I'll just run back down here. I want to run vim so that I can modify some file. I try and run vim, command not found. So I need to sort of, on the fly now, go ahead and install vim inside this container. Once I have vim installed, I'm going to open up Nginx's default conf file. So that should take just another second here to get vim up and running, or vim installed. Now I want to open this from within vim. Great, vim opens, showing the interactiveness between, I don't just have a bash session, I'm now able to run some more sophisticated command that requires a TTY on the remote end. I'm going to modify that now. Instead of listening on port 80, I'm going to listen on port 83.116. So I go ahead and modify that, close that out. Once that's closed out, I'm going to restart Nginx. Nginx is restarted. And assuming everything worked right, I should be able to refresh this, and Nginx is now running on this port. Refresh, and there you are. Welcome back. Welcome to Nginx. So I was able to, see that there were some problems in my cluster, launch interactive bash sessions, launch some random commands inside my container, fix things up, and get things up and running without having to ever SSH onto the agent where this container was running. So those were all three of the demos. I'll jump back to the slides here and just really quickly give special thanks to everyone that helped out with this. It was a huge effort between a lot of people to actually get this going. There's people working on the CLI, there's people working on streaming for requests, there's people working on the security aspects of this. Lots of different pieces had to come together to make this happen in the time frame that it did. So I just want to call all these people out and thank them again for helping with all this. Are there any questions?
So through the whole process, what has determined that you are root in the container?
What has determined that you are root in the container? So in the same way that you launch a normal container or a normal task, when you go to deploy it, you can you set up your container config and you set up your task info and all these things as you pass them to launch your container. You do the exact same thing when you're going to run a nested container session. So you're able to specify what user it is in your container config as you launch that nested container session. Does that make sense?
Is there any DCOS command that says
for DCOS?
Yeah, DCOS CLI. Does it assume automatically that you're logging in as root, or it says?
I see what you're asking. Okay.
Way to say login as
through the CLI command itself, not through, so in general, the API would allow you to specify whatever you want as the user. But through the CLI, we don't have the capability right now of switching the user. That's true. Yeah.
And the user is, so you first did a login, but of course that's through DCOS login.
That's the DCOS.
That's how that, I don't know how that works, but how that interacts with Mesos is that Mesos, because you said it's the built-in auth-n, which is just still a list of principles and secrets, right?
So sorry, so
predefined, so a fixed list of principles and secrets.
Right.
So
which is separate from the actual Unix user that you would log into the box with. Right.
Right, but
DCS login is completely orthogonal, and the user that you want to specify is something that you protect by Mesos ACLs. We added new ACLs for that says which user you can log in as in a debug container, essentially. And I think the CLI just hard codes it to root user. It doesn't set it.
I don't think it sets it at all.
And it picks up what is whatever the acceptor user or something like that.
Yeah.
or it's approved, I think. But it's protected by, so there are ACLs that we added in Mesos for these API calls as well. I think it protects, you can set up ACL saying you can only launch as this user in the container or I guess the container.
Okay. Because now I know the basic stuff, which is the within the repo itself, seems to be pretty much a fixed list of principles and secrets. I don't know whether you guys added some internal.
Yeah, in DCOS itself, there's a very flexible way of adding lots of users and lots of different permissions, which is separate from the Mesos mechanism to do it. But I don't know how that all interacts personally.
DCS has its own modules. Like DCS doesn't use ACLs, Mesos ACLs. It uses its own mechanism.
Okay, but I guess
Everything is modularized, right? We have an authorizer module in DCOS that's different. We have an authentication module that's different.
I see.
For DCOS specific.
So the container that was launched for debugging is kind of compromised, right? Because you could pretty much run anything inside it. So is there any work in future to basically, have a policy around it to automatically kill this container or, somehow?
To kill it in one way?
What?
What do you mean to kill?
After 24 hours or something to terminate this container which has been used for debugging because it's been compromised.
So we do have one thing is like if the HTTP connection to the session disconnect, we're going to kill that debug.
Oh, okay.
Yeah.
So it's going to be.
It's tied to the lifetime of the session.
I guess that's a bit, orthogonal to whether it's secure or not. That's governed by the ACLs. But you're saying once you launch it, it's actually, like the authorizer says okay, but later on you want to say it's not okay and you want to kill it somehow?
Yeah, so I didn't realize that it was tied to the length of your session. So that makes sense.
I said it early on, but if you didn't know until I got to the details, you probably missed that. But
Yeah, it's basically tied to the life cycle of your HTTP
They're
connection.
talking about the nested container itself,
There was a
not the.
Not
What's that?
there was an IP that you used that I felt like came out of
That's good.
nowhere. There was like a 169.
Yeah,
That's AWS.
That's amazing. So I mentioned it, I glossed over the details there, but AWS lets you hit this 169 dot whatever endpoint with curl, and it magically tells you what its public IP is if you hit that. So if you're on an AWS instance, yes, if you're on an AWS instance and you hit that URL, you will get your public IP.
That's like the canonical way to say
Magical.
It's a magical IP that you can hit if you're on an AWS box. Yeah. Okay, are there any questions online? Doesn't look like it. Okay, turn it over to Neil then. Thanks, guys.
Okay, so we have 20 minutes. Neil will go, and then I imagine we're going to be pretty close to 4. So I'm happy to push it till 4:30. If people need to go, well, if most people need to go, then we'll do it next time. But if not, then we can continue. Can I have a quick vote as to 4:30, 4?
Let's finish the demo first and see.
Sure.
You have 20 minutes.
Okay.
Switch the.
Oh, yeah, all right. Lizzie?
I think you have to go to present to everyone for everyone to see it. Oh, he did, okay.
Great. Okay, so this talk is some slides on the work we've been doing on partition-aware Mesos frameworks. So what problems are we trying to solve? We're actually trying to solve 3 kind of distinct problems. So the first is that traditionally Mesos has defined only one policy for what happens when an agent becomes partitioned from the master. So generally in Mesos we try to avoid defining policy for applications. And we want to let frameworks handle, be a little more flexible on what happens when task becomes partitioned, how they respond to that. Second, we use this task set as task lost to mean a lot of different things. It's actually 16 different places where we send it. And those places have fairly different semantics. So we wanted to we wanted to break that down to something a little more granular so that it's easier to interpret how you should actually respond to the status update when you get it. And the third one is there's no signal right now. We tell you when a task becomes partitioned, but it can be useful to know some of the time Mesos can tell you, or the operator can tell you, that a task that was partitioned is never going to come back. So we're looking at how to communicate that information to framework. So a task is not just unreachable, but it's gone forever. So let's go look at these in order. So how does partition handling work in Mesos 1.0 and earlier? So there's a fairly simple fixed policy. So basically Mesos will health check agents. When an agent fails the health check, so if it fails to respond to 5 pings in a row within 15 seconds each by default, Mesos declares that agent removes it from the cluster, removes it from the registrar. Any frameworks that are running tasks on that agent will get a task lost status update, and the slave lost callback will be invoked. Then when the agent reconnects, if it does reconnect, then the agent will be shut down and all the tasks on the agent will be terminated. Notably, this behavior is not consistent if the master fails over. If the master has failed over, the agent will be allowed to reconnect and its tasks will go back to running. So what are the shortcomings, some of the shortcomings here? Well, the first one is that there's only one policy that all frameworks have to use. So the default policy probably makes sense if you're running, let's say stateless applications where you're happy to just spawn another instance of the task somewhere else. But different frameworks might well want to handle unreachable tasks in different ways. They might want to use a different timeout before they launch a replacement task. They might not always want to launch a replacement task. Another variant of that is that a single framework might want to treat different tasks that it starts in different ways. So suppose you had an HFS framework, the way in which you handle a data node failing is probably going to be very different than the way that you handle a name node failing. You might have many hundreds of data nodes, you might have a handful of name nodes. Often, some frameworks are going to want to prefer consistency in that certain tasks might use a resource a resource that needs to be accessed in a mutually exclusive way. So they might want to launch at most one instance of a framework of a task. Other frameworks might want to maximize availability. They might want to say, I need to have at least 5 copies of this task. If I have more, that's not a big deal. So we want to give frameworks the ability to make those kind of choices. And it's also kind of unfortunate that Mesos behaves differently whether the master scaled over or not. So what are we going to do going forward?
Sorry, can I ask a quick question? Yeah. You said that was all pre 1.0, so as of right now, this is already fixed?
Yeah.
Or, okay, yeah, just making sure.
Yeah, so this is a new approach in Mesos 1.1, but it's only enabled if you opt into a capability, but I'll talk about that in a second. So the new behavior is to say that Mesos will no longer shut down partitioned agents. If you opt in this capability, Mesos will also no longer kill tasks on those partition agents when they re-register again. Instead, you'll get a status update that your task is unreachable, which is not a terminal status update. So you find out, okay, this task was running an agent. The master has lost contact with the agent. The task may become running again. And it's up to you to decide how to handle that transition, either from running to unreachable or from unreachable back to running. So it can be a little bit more work if you were just using the default policy, but it does give you the flexibility to choose how to handle those events. And actually, if you really did it properly, because we always allowed lost tasks to come back after the master failed over, really to get this behavior correct, you would have needed to handle that transition anyway. So actually correctly written production framework should have very little changes that they would need to make. So for backward compatibility, that behavior is only enabled if you specify this partition-aware capability. So if you don't specify it, when an agent comes back, and so no matter, regardless of the capability, when the agent comes back, when it re-registers, the agent will never be shut down. So that's a behavior change that applies regardless of the capability. And when the agent re-registers, for backward compatibility, we will kill non-partition-aware tasks on the agent, unless the master is failed over. So the idea is we're trying to emulate the old semantics, where in the past, you could rely in some circumstances on your task being killed. So we'll try to kill tasks in the same set of circumstances. Going forward, we might make this partition-aware capability the default in some future version of Mesos. So something else we added is the ability to find out when a task has been declared unreachable. So this is a new field in this task status message. And the idea there is that if your framework is down when a task or an agent becomes partitioned, it's actually pretty difficult to tell how long it's become partitioned, been unreachable for. So, the kind of way we expect frameworks to respond to an unreachable task is to start a timer, and depending on how sensitive the task is, how important availability is, the cost of doing redundant work, adding multiple copies, you might wait some period of time. And then after that, waiting a period of time, maybe you launch a replacement. So in order to decide how long to wait, we give you this timestamp in the task status, which you can get on reconciliation as well.
Question, you mentioned the task log behavior, a task log behavior change is 1.2?
1.1.
1.1?
Yeah.
Okay, I read it.
Okay, yeah, so we store this set of agents that are, so one change is that we're now storing a set of unreachable agents in the registry. So there are some kind of performance concerns around how to do that I'll talk about in a minute. So that's the first major feature, is basically changing the way that we deal with partition tasks. Okay, the second thing we wanted to look at is we wanted to clarify how we communicate from the master to frameworks about the status of tasks. So right now we're using this task loss status to mean a lot of different things. 16 places, task launch failed, task become unreachable, the task is running an agent that was shut down, explicit reconciliation for an unknown task, and so on. And more than just sending this status in different places, the semantics, like how you would respond to that as that event as a framework author, would have been different. The way that you respond to a failed task launch is probably going to be different to the way that you respond to an unreachable task, or it might be. So we wanted to clarify this. So going forward, we haven't really deprecated task loss yet, but in the future, it will be deprecated. And when you opt into this partition-aware capability, instead of getting task lost, you'll get a set of more granular task states. So we're going to send you task dropped if your task was never launched in the first place. Task unreachable, as we said, if the task is partitioned. Task gone if the task is definitely not running and the agent is shut down. Task gone by operator, and I'll talk about these two in a second, if the operator told us the agent is gone. And then task unknown if the master doesn't know anything about the task, either because the task never existed or because the master state has been garbage collected. So that complements those existing task status values. So the last thing that we wanted to address as part of this work is giving frameworks more information on when tasks are gone forever. So as I said, kind of the way that a lot of frameworks are going to handle an unreachable task is they're going to wait to see if the task comes back. Because when a classical problem is distributed systems, it's very hard to tell the difference between a task that is just slow and a task that's actually failed. So if it's slow to respond, if it doesn't respond within 75 seconds, we'll say that it's unreachable, but it may or may not still be running, it may or may not go back to running. So the way you typically handle that is you use a timeout to try to say, maybe I won't immediately replace it, but I'll replace it after waiting a little while. There might also be cases where it's not safe to replace the task at all. Maybe you are, accessing some crucial resource, some shared disk, for example. You don't want to just start a replacement task unless you're very certain that the original task is actually terminated. So in some circumstances, we can do a little better than this. So in general, we can't distinguish between slow tasks or tasks that we can't contact and tasks that have failed. But there are going to be some cases where Mesos knows that a task is definitely not running anymore. So for example, if the agent was shut down, we know the task, gracefully shut down, terminates all its tasks, we know that task is definitely not running. Then if we can communicate that to frameworks, they could respond more aggressively. For example, they could cancel their timeout and do something more promptly, or maybe they could replace a task that they're really sensitive and they want to make sure that the previous copy is definitely gone. So we're looking at sending this task gone status update when Mesos knows that a task is definitely no longer running. So again, that's an optimization. It's not something you can rely on, but as a framework, you could potentially respond, give a better user experience. So we could send that basically when the agent is basically shut down, either by say user 1 or when it's taken down by the machine down endpoint. So that would probably involve modifying the shutdown sequence so that the master knows for sure that the agent is shut down before we send this task on update. Now there's another case where Mesos doesn't know their task is gone forever.
Sorry, can you go back one? So it says gone is per agent, not per task?
Yeah, so the idea here is that we are kind of using task status updates to describe a transition that applies to the whole agent.
So every task that, when you get this, that means every task that had been running on that agent is gone?
Right. And you could make it granular and identify situations where just the task is gone. That would be more expensive for we would have to store all the task IDs rather than agent IDs. So the idea is mostly the cases we'll write about here are when the whole agent is gone. So you can't, access its state.
It's a little weird though, because the other task status updates are all per task.
I mean, task unreachable is also basically per agent. There's never going to be a case where one task in an agent is unreachable and the other ones are still reachable. So yeah, I mean, we've also talked about having a way to look at the lifecycle of either whole machines or volumes.
Right.
But right now, we're kind of
it's all through this one
status
update mechanism.
So task gone is for the case where Mesos knows that the agent is gone. It can prove that. But there are other cases where Mesos won't know that, but the operator has some kind of out-of-band knowledge. So you can think about in a cloud scenario, let's say that the operator knows that a spot instance is going to be terminated, or the operator himself has terminated the cloud instance. Or you might have what's called a stomith mechanism. So a lot of, some distributed systems will actually build in mechanisms where, let's say, if you're shipping a file system, you want to take over a shard of the file system that was owned by one node to really make sure that the node that owned the previous task that owned that shard is gone. You might have some out-of-band way to make sure that the previous task is definitely terminated. So you could scriptably turn off the power to the old machine. So exactly that knowledge about when an instance is terminated remains kind of outside scope for Mesos, but we want to provide a way to communicate that for the operator to tell Mesos when they have that additional information, so that frameworks can take advantage of that knowledge.
Just one question. So the agent gone here is not the machine of the agent gone, or is it just the slave ID or agent ID is gone?
Right. So that's something. So this last part is not implemented yet, and we're still kind of refining the exact semantics. And that's one thing we're trying to decide. Or there's basically, we could say that the agent ID is gone. So that agent ID is no longer running. All the tasks that it was running are gone. But there's also people would like to know when the volumes, the resources that agent had are definitely not accessible anymore. So depending on which way we go here, like you could also add some kind of volume reconciliation or volume lifecycle. So that's kind of still up in the air, exactly how to interpret this.
I see.
What would the agent ID being gone be used for?
For example, if you gracefully shut down, an agent, right? You know that the agent is terminating all of its tasks before it shuts down. So you know that.
So you know the framework's task is gone.
I think it's originally intended for the reboot case.
Yeah.
Where when we rebooted the agent, all the tasks are definitely gone. You want to tell the framework. But that's less of an issue now. The work these guys are doing with keeping the agent ID across reboots. So that's less of a use case where that's useful. But I'm basically saying your task is definitely gone, but your volumes and stuff might still be reused for a new agent that comes up. So it's not that useful for stateful frameworks, I guess. So that, yeah, Mesos in task on task on operator is not implemented. This is just design used to carry out.
So yeah, so as I was saying, like at least what we're talking about now wouldn't guarantee that the resources, in particular the persistent volumes associated with that agent, don't come back with a different agent ID. But we potentially might change that because that's certainly something that people care about. So one last thing. So we need to be careful about how we manage state. So before we did this work, Mesos kept a list of registered agents in the replicated log in the registry. So that list is going to be bounded by the size of your cluster. So now we're also we'll also be keeping at minimum a set of currently unreachable agents. And if we had gone and gone by operator, we would also need the list of gone and gone by operator agents. So unlike the set of registered agents, set of unreachable agents could grow without bound. So if you had some cloud scenario where you bring up a lot of nodes and they become unreachable, and then you bring up more, we want to be careful to make sure that we don't use too much space in our replicated log. So the approach we took was adding a garbage collection mechanism. So we're going to limit the size, the number of unreachable agents to 100,000, and we'll forget about an unreachable agent after 14 days by default. So the consequence of that is that you can't precisely know whether you might see unknown when you reconcile for the state of a very old unreachable class. So the idea here is the frameworks would at least be able to handle unknown somewhat gracefully. In terms of schedule, so 1.1 shipped with the change of the partitioning policy. 1.2 did most of the new task statuses, and then 1.3, or we're working on task on right now, and that potentially get into 1.2, 1.2 or 1.3. So thanks very much. Happy to take questions.
So the amount of data that gets stored within the replicated log, I guess the size of it, I guess, kind of depends on how what kind of data goes into the slave info, I guess.
So we're only storing slave IDs.
Just
not slave info.
Only slave IDs?
Yeah. So slave info for all the registered agents, but only slave IDs for the unregistered ones.
Okay.
So all the new, if an older framework user using some version of the schedule API, Daemon API, which was working with, let's say, Mesos 1.0, connects to something like 1.2 or 1.3, where new task statuses are coming in. So that framework, I think, would understand only task lost, because it's an older framework, but it's going to get these new task statuses.
No.
So how would the master figure out whether it should be sending task lost versus these?
So it looks at whether the framework presents a partition-aware capability.
Oh, that particular part that it has to.
Yeah.
Okay.
You will see some differences. Like if you had a script that was looking at metrics on the master, for example, and looking at how many lost tasks there were.
Sure.
If you have a framework that launches a task that is partition-aware, that task becomes unreachable.
Yeah.
It'll increment the task unreachable metric, not the task loss metric.
Oh, okay.
But in terms of framework behavior,
It's in the macro.
Yeah.
Do you look at older frameworks that actually rely on the agent dying as opposed to its tasks dying?
You can. It's conceivable. I don't know of any, and we emailed the dev list to say, like, if this is important to you, let us know, and we put it in the change log. Anyone?
Like with 1.1, the emulation is just at the task level, not the agent.
Right. Yes.
Presumably, I can't think of a reason why people would might only care about the 80 going down, and they should probably care about the passes. But I'm just curious if there were like bizarre cases that you came across.
We haven't come, I mean, you could dream something up that'd be pretty obscure, but yeah, I haven't actually come across,
Cool.
Great, thanks.
We're gonna skip the roadmap updates. And we have 1.2 release discussion here. I don't know if there was like an announcement that you wanted to make or if you actually have a discussion. If you.
Yes, take it for the next one as well.
Okay.
Yes, yeah, that's what I said, like, are there any things that people want to know about too, that's not reflected in the dashboard,
I see.
kind of thing.
Okay.
So we're getting pretty close to it.
When is that? When is?
We wanted to do it this week, but we still have some blockers left in the dashboard, so it might be next week.
Okay.
So.
Maybe just send out an email for that with tell people on the list, and then in 2 weeks we might over a call. So maybe we'll do like RC, check it out, kind of thing.
Yeah.
Okay, great. That's it for this week. See you in 2 weeks.